So today we are going to discuss about S7 blocks. Okay, so in Siemens, programming blocks and other blocks are divided into three different parts. Okay, so here these blocks are called as S7 blocks. So here you can see we are having pre-programmed blocks, user programmable blocks, and data block memory. Okay, this is additional memory. Okay, data block memory. So pre-programmed blocks, these are available in your library and CPU memory, and also known as SFC and SFB blocks. Okay, SFC stands for system function and SFB stands for system function blocks. Okay, these are the just like predefined blocks for some additional or special functions where you need to do a lot of calculations. Okay, or some formulas there. Okay, instead of that, what Siemens has done is they have already created uh, some logics. Okay, some blocks. Okay, uh, like they already made some programs. Okay, calculations, formulas. Okay, depending on the formula, they already created all those blocks, and simply you can apply these blocks. Okay, so that we call it as pre-programmed blocks. Okay, means the same logic is there, so 10-15 times I can simply use the same block, but I can give it different addresses. Okay, so that's the advantage here. Now here you don't need to make all those calculations again and again. Okay, that's the reason. Another thing is we are having user programmable blocks. User programmable blocks are known as OBs, organization blocks. So these OBs are also having some numbers, right? So OB number 1, in which we are doing the programs. Okay, till now. So this OB1 is a main program block or called as main routine. Okay, so other OB numbers are also there, like 10 to 17, 20 to 23, like that. There are many OB groups. Okay, these blocks are in terms of a group for different application. Okay, and these OBs are called by your CPU only. Okay, these OBs are called by your CPUs only. Apart from that, you are having FCs and FBs. Okay, FCs and FBs. So whereas FCs are called as function, FBs are called as function blocks, and these FC and FBs are called are also known as subroutine blocks. So what is a subroutine? We call it as a subprogram also. Okay, in which if I'm having 10 machines, okay, for these 10 machines I'm having some different programs, right? So can I write all these different programs for these 10 machines in a same block on OP1? Right, it's not possible, right? Because we will be having large number of networks. Okay, if you have to go to some logic number 7 for machine number 7, okay, so you have to scroll down up to network number 500 something. Okay, suppose each machine is having some 100 150 networks program, right? It will be very complex, it looks very complex, and if you have to disable any program or any machine program, so it will be difficult again, right? So instead what we are doing is we are dividing these blocks, okay, these programs into different blocks. Okay, we are writing these programs into different blocks called as FC and FB, or also known as subroutine blocks. Okay, and we can call these blocks in main block, that is your OB. Okay, okay, we are calling these sub blocks into the main blocks one by one, so your block is executing that logic step by step. Okay, now next block is called data block. Okay, memory. Okay, these are the actually memory blocks for storing data, just like we are using bit memory. Okay, for storing values. Okay, temporary values. So here also DB memory is a additional memory, but DB is by default a retentive memory. Retentive means which retains. Just like if there is a power failure also, the last value, whatever the last value is there, or the machine has stopped for some time. Okay, so it will store the last value. Whereas in bit memory, okay, it is not storing that last value. It will, once you give a reset, it will reset the total RAM memory. Okay, generally this bit memory is a RAM memory, whereas data block is a ROM memory. Okay, so this block is divided into two types. Okay, as a shared DB or instance DB. Okay, shared DB and instance DB. So what is this shared DB and instance DB? We'll discuss further. Now here you can see as our scan cycle, okay, in which we are having a main block, right? We are having a main block. So here what we are doing, we are having different logics, okay, as we have discussed, right? So different logics we are writing in different blocks like FC1 in FCs or FB DBs, okay, FB and DB. So for FBs it uses additional memory, okay, called data block memory, right? So for storing the FBs, whatever the logic is there in FB, that logic status or values will be stored in that DB memory. Okay, that's the advantage with the FBs plus DBs. Whereas in FCs, that is not require any additional memory, okay, because it is using your CPU memory itself. Okay, CPU memory in the means like for storing your bit memory, MW address, okay, or DB also, that also you can use. Okay, so here what happens during execution? What is the first call here? FC1, right? So your PLC goes to this FC1 block, okay. So in this FC1 block we are having logic 1, okay. Only this block is scanned, okay, only this block is scanned, it is not scanning other logics, okay. Then come back to OB1, same way it again go to the FC next call, then scans only FC2, then come back to the main block. So one by one it is scanning a single block, okay. So what happens here, it will execute your logic faster and easier way, okay. So that's the advantage of using these subroutines. So it's like unnecessarily I don't need to means your CPU does not need to scan all the logics. Suppose if I am disabling FC2, disabling means I don't want to execute this logic number 2, okay. For that I am having one input, so with that I can make the input off so that it will not execute this FC2, it goes to the next block. What other block is there after FC2, 3, 4 or FB, it goes to the next logic. Means this is how we can skip any logic also, okay. Unnecessarily it will not scan the unwanted logics, okay. That's the advantage here, okay. So your CPU will have less load, so the execution will be faster, response of the CPU will be faster, okay. That's the another advantage of subroutine blocks. Now here we are having shared DB and instance DB. So instance DB means, okay, here instance DB means here you can see FB plus DB, okay, FB plus DB. I'm giving some DB memory, okay, for that particular FB block. Means whatever logic you write in that FB, that logic value or status, okay, whatever the output is there, that will be stored in that DB memory. Means that DB is particularly assigned for that FB only, okay. It is assigned for that FB only, for that particular FB. So what happens here, uh, if I want to store some data, okay, some value, okay, or you can say if my inputs are not available, okay, it's not working or not available, for that also I can change the values from DB, okay. It's like a backend memory also you can use, okay, bypass memory also, as a bypass address also you can use DB memory, okay. That we see practically, okay, how we can use. So this DB which is assigned to one FB is called instance DB, only for that FB, okay. Shared DB means it can be shared anywhere in the logic, okay, in total application also. So as you can see here, difference between FC and FB. FC uses CPU memory, whereas FB uses additional memory, that is DB memory, to store the logic values and status, okay. Now next is one FB uses one DB, which is by default a retentive memory, okay. This DB is a retentive memory. This DB memory is known as instance DB, okay. It stores the information of particular FB logic only. Next, shared DB. Shared DB can be created for storing different data types, okay, for storing different data type values like bit, byte, word or double word format, okay. Here also it is happening the same, because in FB also we are using some bit, byte, word, double word addressing, okay, for input addressing or for storing some memory, right. So Here also it is taking different data type, but shared DB means you can use share this in the total logic, okay, in total application, not in only one AP, in anywhere in the logic, just like we are shared MW, MD, okay, bit memory, byte memory, okay, that way. Next, data blocks are memory blocks. For example, total block size is 65536 bytes. Okay, it's like a total memory area. Okay, from that memory area we are creating DBs. Okay, so like for example, we are having DB number 1, DB number 2, DB number 3, like this. It depends on the CPU memory size. Okay, so not only 65536, we can have more bytes also in some CPUs. Okay, so here if I am using like DB1, okay, so I can share the size of this DB from the total number of bytes. For example, you can see DB1 uses 100 bytes, okay, and DB2 uses 250 bytes, etc. So means out of this total bytes, okay, we are using only 100 bytes for DB1, 250 bytes for DB2, like that. Okay, so minus 350 bytes out of this 65536 bytes means total memory area is there. So how much size you need, you can use from this total number of bytes. Okay, that's the thing here in the DB. Okay, suppose if I'm using one single byte for 1 DB, in such case I can create how many DBs? Total 65536 DBs. Okay, so there's a maximum DBs you can create, but that's not possible, right? Because in 1 DB if I'm using like 100 bytes, so minus 100. Okay, if I'm using some another 250 bytes in DB2, so minus 250 again. So like that, we are sharing this total number of bytes between this DB1, 2, 3, like, okay, that depends on your logic, okay, and the size required, okay, in your structure. Okay, now we see the data block addressing format here. For example, we are using DB1. Okay, we are creating DB1. Okay, so for DB1, here you can see DB1. First, we have to give the data block number. Okay, DB1. From which data block we are taking the address. Or if you are taking the address from DB2, so first we have to mention DB2 here. Okay, DB2 dot, like that. Okay, then DBX0.0. DB means just like in bit memory we are using M as a symbol, right? So here we are using DBX as a symbol for bit address. Okay, DB is a symbol for instead of M for data block, X is a symbol for Boolean, okay, for digital address, okay, for Boolean data type. Then byte number dot bit number. So DBX 0.0 up to DBX 0.7. In which block? DB number 1. If you are creating DB2, so it will be like DB2 dot DBX 0.0 to 0.7. Okay. Now, next, what happens here? Again, the address byte number changes. So 1.0 to 1.7. Similarly, 2.0 to 2.7, 3.0 to 3.7. Like this, this number of bytes, how many bytes you use, this address will go on. Okay. Next, so 0 to 7 bit numbers is called 1 byte, right? For that, we're having byte level address for that. So DB1 dot DB. Okay, just like MB0, MB1, right? In DB1, we are using DB B0 instead of M, DB we are using, right? DB1 dot DB B0, DB1 dot DB B1, like that, this will go on. Similarly, for word address, word format, word level format, DB1 dot DB W0, right? If I add 2 bytes, it becomes 1 word. Similarly here, DBW2, okay? For double word address, it will be DB1 dot DB D0, DBD4, DBD8, like this it will go on. So we are also sharing this memory, okay, in terms of byte, bit, byte, word and double word formats. Okay, so it is similar to your bit memory only, but here we are to define with a DB format. Okay, DB1 in which block number dot DB okay, instead of M, okay, and remaining is the byte number and the type. We are using byte, word, double word, okay, in this format, okay. So this is about the shared DB. Now, or the addressing formats here. Next, we see how to create FC. Now, let's see how to create FC. So first, go to your schematic manager. Under your project, expand it. Right click on the blocks. Right click on the blocks. You can see insert new object. In this, you can see we are having different block types. Okay, organization block, function, function block, data type, variable, table. Right. So you have already seen how to create variable table here. Now, next we see function. So when you select function, it is showing FC1. Okay, so here the name will be in the same format, FC format only. So FC1, 2, 3, 4 like this in sequential order we can create. Or in case like if you want to create another FC number directly 20, 30, 40, 45 something, that also you can change. Only number you can change. Okay, for that it has given this option. Okay, but you want to give any name for which logic you want to create this FC, that you have to give in symbolic name. Just like if I give some name like logic 1, okay, in created in language ladder, then so okay, you can see here FC1 is created here. Double click, open this block. Now here also you can see we are having the same thing, okay, networks, where we can do the logic. Okay, so here I make one logic here, start, stop, that latching circuit here, say I0.0, I0.1, Q0.0, and Q0.0. Okay, now I save the block. Now I open OB1 from here. Now in our instruction list, okay, window, you can see we are having FC blocks. Expand these FC blocks. You can see FC1, logic 1, okay, the block which we have created. Now you can drag and drop this block on your network. Again, you can see EN and ENO. EN means input enabled, ENO means output enabled. Means this block you can directly call without any input also. Okay, if these symbols are there. Now, if you want to control your logic using some input, for that you can take some NO or NC contact, depends on your requirement. Just enter the address, then save this block. Now go to schematic manager and select both the blocks, because we have created another block, program block. So we have to select and download both the blocks. So select this and download from here. Say yes, yes, all. That's it. Okay. Now in runtime monitoring, here you can see in our FC logic, okay, FC block, we have made a logic start stop, right? So I 0.0. So when I give this input, is your output going on? No, right? Now, because this block is not called yet, because this input is off. Now I make this I0.2 on. Now this block is called. So when I give this input here, the output is working. And when I give stop, it will stop. Now in case like if you have started the output in the block and you are disabling the call, okay, this I0.2 I'm making it off. So what is the status of your output is still on. Now if I try to give a stop command, is it stopping? No, because this block is not called, but whatever the last status of the output was there, it is holding. Okay, until you call the block again. Okay, here this output remains on, so call this block again, then you give the stop. Okay, if you don't want to execute this logic, you can disable by giving this input command. Okay, this is one way by using this input, or if you don't need this input, you can delete this, you can directly call this block. Okay, so just save it and you can download it from here in second time. Now, so when I give the input here start, stop, directly you can execute because we are not giving any command. Okay, so directly you can execute. Okay, so this is another way. Now this is one thing. If you see in FC1, you have made this logic, right? This is only one network. Suppose in case I am having a logic for one machine, okay, which is having some 50-60 networks, okay, or it's a big logic, okay, complex logic. But if I'm having 10 similar machines, means 10 identical machines, for example packing machines, okay, 10 packing machines are there. For this 10 machines I'm having the same logic, right? Logic is same, but what we need to do by using the same PLC, if I have to control all the 10 machines, I need to give separate addresses, right? Different addresses, not the same address. Okay, in such case what you need to do is you need to make the logics 10 times, okay, in different blocks, like FC 1, 2, 3, like that. You need to create 10 FC blocks and we have to write the logic again and we have to give the different addresses. Instead of that, we're having one option called parameters. Okay, we are having another option called parameters. Okay, so how to use these parameters? We see that example. I close this block. Now I create one more FC. Right click on the blocks in Semantic Manager, create function, say FC2. Okay, so here like using parameters. Okay, I'm giving some name like using parameters. Say okay. Now double click open FC2. Now here what we are doing is, here you can see on your toolbar, okay, just below your NONC contacts, you're having one window. Okay, so you need to drag drop this window. Okay, this is called interface window. In this interface we are having in, out, in, out. Okay, so this parameter slots. Okay, so in this we have to enter your parameters, like for inputs, input types, like we are having start. Start is input, right? Stop, stop is also input. Then you can see we are having out and in, out. So what's the difference between in, out? In, out means just like we are using latching. Okay, output we are using again as an input in parallel to your start input. So you are using as input as well as output. So that is coming under in, out. So such input I will define like motor 1 as a in, out. Now I define one more output as motor 2 only under output. Okay, because I will use this motor 2 only as a output. So let's see that example here. So I make this same NONC latching circuit here. Say start, I'm giving the names. Okay, I'm only giving the names. There's no address here, right? Stop, motor 1, one more network. In this, again motor 1 I am using as input to start motor 2. Okay, so motor 2 I am using only as a output, whereas motor 1 I am using as output as well as input. So I have defined this in out. Okay, now save this block. Now open OB1. In this, I take one more network. Same from FC blocks. You can see FC2. Okay, double click or drag drop. You can see the block here. Now here you can see the difference here. This FC1 and FC2. Right? In FC1, what we have done, we have made a logic. There only we have given the addresses I0.0, Q0.0, right? But this block we can call only one time. Only one logic. Okay, single logic, one time you are calling. But same logic we have to call multiple times. For that we are using parameters. Okay, here it is showing the start, stop, motor 1, motor 2, what are the name we have created in parameters. Now here it is asking the address. So here I give the address I0.2, I0.3 for stop, next Q0.2 for motor 1, Q0.3 for motor 3, 2. Now I save this block OB1. Now what we need to do, again we need to download this. So here I go to the schematic manager, select OB1 and FC2. Download these two blocks because FC1 we already downloaded, so I'm not selecting it. All S and OB1. You can check it online. So when I give this I0.2 input, you can see these two outputs are on, right? So here it is showing one status 2 times because motor 1 you use as in and out. Okay, 2 times. That's why it is showing as input as well as output. Now, so when I give stop, I0.3 is off. Okay. Now, suppose if I want to call the same logic once again, I take one more network, again call this FC2, the next network. Here you can give the another address 5, Q0.4 and Q0.5. Okay, now I save this and download. Okay, so as already FC2 is downloaded from there, schematic manager, I'm downloading only this change which I am making in OB1. Okay, now so when I operate this I0.4, this logic is working separate, right? So when I give the previous one, that is also working separate. So you can give the stop, right? So this is how you can make the logic only one time using parameters. Okay, and you can call the same logic many times. Okay, using different addresses. Okay, that's the advantage of using parameters. Okay, this is about the FC in 2 methods.